Sketch the graph of a function that satisfies all of the following conditions. Okay, what you have to watch out for are the x values. So 0, 2, 4. Okay, there's also 1 and 3 involved. Okay, so we create a box which summarizes information about x, okay, f prime, f double prime, and the function itself. And you put the number that's given. So 0, 1, 2, 3, 4 are the numbers that we have to consider. So 0, 1, 2, 3, and 4. The space between the numbers represent all numbers that are between 0 and 2, for example here. All numbers that are between 1 and 2, and so on. Okay, so it says the first derivative is equal to 0 at 0, 2, and 4. It's positive when it's between less than 0, and it's between 2 and 4. Okay, it's negative when it's between 0 and 2, or after 4. Second derivative, between 1 and 3 it's positive. Okay, the second derivative is negative if it's less than 1 or greater than 3. Okay, so this tells me, even though I don't know exactly what the values are here and here, this is an inflection point because the concavity changes. Okay, sorry, oops, this is supposed to be negative here, right? Negative, negative, negatives. Also inflection point. Okay, here it's going up, and then it's going down. Okay, up and down, and it's concaving down. So it's doing this kind of curve. This is definitely a local max. Okay. Okay, so here it's going down and concaving up, right? It's going down and concaving up. Here it's going up and it's concaving up. So this is definitely a local minimum. Okay. Here it's going up but concaving down like this, and down and down. So this is another local maximum. Okay. So important numbers are 0, 1, 2, 3, 4. Okay, so there's a local maximum at 0. So let's say that's like that. Okay, so they haven't actually given us, at 0 it's 0. Oh, actually, you know what? These are not the function values. These are the derivative values. So let's say this is the local max. Okay, it's arbitrary. We can pick higher or lower. Right? And at 2 it's a local minimum. So at 2 I'm just going to pick a low. That's the local minimum. And at 4 it's another local maximum. So I'm going to pick it like that. Okay. At 1 there's an inflection point. So you're supposed to concave down until you hit 1, and then concave up again. At 3 it's also concaving. The concavity changes. You got to change it at 3. Okay, so this is an example of which satisfy all the conditions that's given.